morning. Happy Tuesday to you. Today we're going to be in our math book on page 219. We are going to be factoring to compare fractions. Problem number one, here we go. We've got two numbers. Actually, at the very top, let's talk about the two fractions. They want us to compare those two fractions. And those two fractions that we are comparing is 3 over 10 and 5 over 14. Now, you know how to compare those by just cross multiplying, but this day, we're going to be using factoring to compare them. So, let's start by looking at 10 and 14. We're going to use a factor tree. We've learned this year. You're going to think, what two numbers can I multiply to equal 10 besides 1 times 10? That's 2 and 5. Both of those numbers are prime, so we're going to circle them. What two numbers besides 1 times 14 can I get to equal 14? That's 2 and 7. Great job. Now, we're going to take those two numbers and we're going to go now on down the page where it has 10 and 14 and it says list the factors of 10 and 14. Now, you may be used to saying 1 and 10, 1 and 14. That's true. Then you could also say 2 and 5, 2 and 7. But there's no point today in listing the ones and the numbers themselves. So we're just going to go with 2 and 5 and 2 and 7. Now, looking at the numbers that we wrote down, they have a number in common. That number is 2. So circle it. That is your least common multiple. So go ahead and put that on your paper now. Least common multiple. Now, to find the GCF of 10 and 14, we're going to multiply these numbers that we've used in listing the factors. We're only going to write down 2 one time. And here's the reason why. Because they both had it in common. Then the next number that we need to write down is 5. The next number we need to write down is 7. Now, we're going to multiply 2 times 5, which is 10, and 10 times 7, which is 70. So that tells me that 70 is the GCF of 10 and 14. Now, let's go back to those fractions. And those fractions at the very top there of number 1 were 3/10. And then on this side we have, my book is so small, 5 over 14. All right, so the new bottom number is going to be 70 because that was the GCF. We're going to put 70. Now, 10 times what equals 70? 7. So if I said 10 times 7 is 70, I got to get a new top number on this fraction known as the numerator. 3 times 7 would give me 21. Now, over here, 14 times what equals 70? Well, you may not know your 14s, and that's okay. You can think about this for a few minutes, but I know that it's 5. And the reason why I know it's 5 is not because I'm your teacher or because I have an answer key. It's because 4 times 5 is 20. There's my 0, carry my 2. And then 5 times 1 is 5, plus that 2 would equal 70. Now, since I multiplied 14 by 5, I'm going to multiply 5 by 5, and I'm going to get 25 over 70. Now, you can look at these new fractions that are equivalent. 3 over 10 is the same thing as 21 over 70. Excuse my sloppiness there. And then 5 over 14 is the same thing as 25 over 70. That means they're equivalent. So now, because they have the same bottom number, you can look at the top number and tell which fraction is bigger. It's going to be 5 over 14 because 25 is bigger than 21. Now, let me make sure there's nothing else that I need to go over. Nope, that's it. So, use your factor tree, then list the factors, but you don't have to use 1 and that number. Circle the 1 if they have 1. That is common. That is the smallest. That would be your least common multiple. Up here it was 2. Then take and multiply the numbers that you used up here to find your factors. That was 2, only one time, 5, and then 7. Multiply all of that and you'll get your new bottom number, your new denominator. Then take and make an equivalent fraction. Look at the top number and that will tell you which fraction is the greatest. I hope this helps you guys. Try number 2 and I'm sure you're going to do great. Appreciate it.